Hello. Hello. Okay, we want to determine whether the series sum n equals 1 to infinity of n to the n over n factorial converges or diverges. Okay, so to do this, I want to use the ratio test. Okay, so part of the reason why I want to use the ratio test here is looking at this factorial. Anytime you see a factorial, you want to use the ratio test. No, maybe not always, but it's a strong indication that you want to use the ratio test. Okay, so then if we're using the ratio test, we're taking the limit as n goes to infinity of absolute value n plus 1 to the n plus 1 all over n plus 1 factorial divided by n to the n divided by n factorial. Okay, so as several of the videos you've watched now have explained, uh, so these are both, everything in here is positive, so we can drop the absolute values. Then we can rewrite this by multiplying by the reciprocal of the denominator, so that's n plus 1 to the n plus 1 all over n plus 1 factorial times n factorial divided by n to the n. Okay, so one of the things you saw in one of the other videos is that the n factorial cancels with the n plus 1, which is why we like to use the ratio test here. But another thing you'll notice is we have an n plus 1 here with an n plus 1 to the n plus 1 up here. So we can cancel one of the n plus 1s. So what we're left with here is the limit as n goes to infinity of, I'll write it like this, n plus 1 over n to the n. Okay, so I'm going to write this in a slightly different form. Okay, so rather than think about it like this, I want to think about it like this. Okay, so if we plug this in directly, we should get 1 to the infinity, okay, which is an indeterminate form. Okay, so with this indeterminate form, here's how we can evaluate this. Okay, so what we're going to do, the trick that you should have learned in Calc 1, is we're going to take the limit of the natural log instead. Okay, so L is the limit as n goes to infinity of the limit of the natural log. So this is natural log of 1 plus 1 over n to the nth power. Okay, using log properties, we can pull the n out front. So this is limit n goes to infinity of natural log 1 plus 1 over n times n, which is indeterminate form infinity times 0. So we'll rewrite this one last time so we can use L'Hopital's rule. Limit as n goes to infinity of natural log 1 plus 1 over n divided by 1 over n. Okay, so now if we apply this limit, we take the limit as n goes to infinity of 1 plus 1 over n. It's natural log of 1, which is 0. And then we take the limit as n goes to infinity of 1 over n. That's also 0, so we can use L'Hopital's rule. Okay, so using L'Hopital's rule, this limit is then, we're going to have to use the chain rule here. This should be 1 over 1 plus 1 over n times the derivative of the inside, which should be negative 1 over n squared. And actually, I have not taken the limit yet, so we need the limit. Divided by derivative of the denominator, which is this. These are going to cancel. The 1 over n squareds, negative 1 over n squareds cancel. Okay, so we're left with just the limit as n goes to infinity of 1 plus 1 over n, which should just be 1. Okay, so the limit here is 1. So if the limit here is 1, this was the limit of the natural log. So this limit here, this is all sort of off to the side. This limit here that we were interested in is really going to be equal to e to the L, which is e to the 1. And e is strictly bigger than 1, and that tells us that the series diverges by ratio test. Thank you for watching.